Hey everybody, I'm Natasha. I'm one of the product managers here at Datadog. Before I welcome onto the stage NatWest, who you're all here to listen to, we wanted to take you through a little bit of our journey for how we built cloud costs and how Datadog actually uses cloud cost management internally to save on our own bills. I'm sure most of us have heard from our leadership that we need to reduce cloud spend, right, while delivering value, performance improvements, and everything else. And that's because for most of you, and definitely for us at Datadog, our cloud bill looks a little something like this, just up and to the right. But the challenge isn't just the rising costs. It's trying to figure out what value, what business value those costs are driving. And that ended up being challenging for us for two big reasons. The first is that when we use multiple SaaS and cloud providers, and there's hundreds of services across them, it was becoming really challenging to figure out who was actually spending what. And the second was that our engineers, as good engineers do, were always doing performance improvements, but it was really difficult to figure out the cost impact of the performance improvements they were doing consistently. We face this problem internally at Datadog, so let's take a look at how we use these problems to actually build out the cloud cost product. First, we ingested all of our cloud and SaaS providers into Datadog's cloud cost management product. And by the way, for any of you that are using and hopefully loving Datadog, you can actually ingest the cost of Datadog into cloud cost management. And this is completely free. So any customer using Datadog today can already ingest their Datadog costs into the product to get a little bit of a taste. This gave us a granular daily breakdown of the costs that we had in near real time instead of waiting until the end of the month. But then we needed to start allocating these costs back to teams and services that were actually using them. We, like many of you, use Kubernetes to help us orchestrate workloads and meet customer demands. But in shared environments, it's really hard to know who's actually spending what. So we built container cost allocation. We take the observability data, like usage at the pod level, and we combine it with cost data to actually show you who is using what in our shared Kubernetes environments. Once we had all of our costs allocated to the specific teams in shared environments and in other providers, we were able to take this graph and look at it by team. This was a much more actionable view. And it started to make it easier to put costs in front of teams and start creating cost awareness. Knowing how much people spend also makes it easier to know how much people could save. Datadog then built a cloud cost recommendations feature across all three public clouds to see how much money you can save in the three public clouds. And we started putting all of this in our own Datadog dashboards. Now, I can't show you how much Datadog actually spends on the cloud, so we're going to look at this demo web performance demo data here. This is like a pretty typical Datadog dashboard, right? You've got some key KPIs, error, latency, things like that that engineers are already looking at. We want cost to be just another thing that engineers get access to in the same pane of glass. So we added costs to our existing dashboards. We also added those recommendations that Datadog is generating to these dashboards. You can see here our web store service actually has about $350,000 worth of savings opportunities they could act on. And the top recommendation is just to move S3 buckets from standard to intelligent tiering. All of these recommendations are generated using really granular observability data. So our teams had confidence that they could take action to reduce costs without harming all of their performance or impacting our end users. Now our team sees cost recommendations and costs in every workflow they have today, whether that be the IDP software catalog, containers app, dashboards, notebooks, monitors, and more. And cost visibility helped our engineers accomplish two things. One, they weren't looking at costs in a silo. We were looking at costs in terms of reliability, scalability, performance, and more. And every performance improvement, we were able to start linking to cost savings. And we were able to celebrate cost savings the same way we celebrate performance improvements. And by the way, we really do this at Datadog. We have a performance wins channel that everyone posts in for any performance or cost-related wins. And you'll see even our CEO jumps into the channel and congratulates us on a job well done. Our goal wasn't just to track costs. We really wanted to build a culture where cost is a shared responsibility. And the impact was huge. Datadog saved over $17 million every single year, starting last year alone, and this number keeps going up. We calculated this for a blog post we wrote that you can take a look at after the talk, and you can see some of the key optimizations we made that helped us save this much money. But like I mentioned, we didn't build this product alone. Obviously, we started to build it for ourselves, and we found that many customers like yourselves have the same needs. we started to partner with customers very closely to build out cloud cost management. And we want to bring up to the stage Mike and Antoine from NatWest Boxed, who are one of the customers we partnered with on a bi-weekly basis. Thank you.
Thank you very much. Oh, that mic is already on. Cool. Hello, everyone. Thanks for making it to the last session of the day. You're very brave. I'm assuming you're very dedicated and can't wait to hear about how you're going to save some dosh today. So thank you very much for making it. So yeah, today, essentially, we're going to talk about NatWest Boxed's journey to cloud cost optimization. Essentially, we're going to share how we kind of came to understood, allocate, and to ultimately optimize our cloud costs within our Kubernetes first environment. We'll walk through the challenge, some of the solutions we implemented, and some of the lessons we learned along the way. So we'll essentially divide this into a few sections. We'll first start telling you kind of like how our infrastructure works currently, or how it's designed. We'll then talk about our partnership with Datadog, how that worked, and then we'll take you to the different steps we took to eventually improve our bill. So with that in mind, I'm going to pass on to our next slide. A bit about us first, so you kind of know in which kind of field we operate. NatWest Boxed, also known as simply Boxed, essentially operates as a banking as a service provider. This means that we essentially provide a bank in a box to companies that can then essentially provide their own services. You can think of this as if Tesco wanted to build Tesco Bank these days, rather than building it from scratch, they'd come to us and say, give us a bank, and then they'd white label it out. And so we built this from the ground up. So it's all Kubernetes cloud native based, and with all the benefits of the cloud, one of the key challenges we get is the cloud costs, effectively. This is especially true for a platform like ours, and so we'll be talking about that today. I am Antoine. I'm the engineering manager for the core platform team, and with me today is Mike, who is the tech lead for our team. So with that, we're going to set the scene. I'm going to give it to Mike.
Cool. So yeah, we just wanted to give you an understanding of where we were, what our infrastructure looks like, how those choices have made some of our stuff a bit complex to work with. We've got lots of cloud accounts inside multiple different cloud providers. This is a very simplified view. We've got some accounts, like the platform ones, where we run them. Lots of teams deploy into them, but the sort of AWS side is ours. And we run that across both AWS and GCP. We've got a multi-cloud setup. We've got individual accounts like security's one, where they do stuff they don't tell us about, because we're not allowed to know what the security stuff's supposed to be, because they're trying to protect against us as well. We've got data engineering who do loads of analytics, and that's all run by themselves in sort of very DevOps fashion instead of platform as a service. And these lead to quite a sort of different operating models in those different accounts. The biggest one, of course, is the sort of central platform. That's where like 90% of our stuff is and 90% of our cost goes. We've built a whole thing with a very Kubernetes-first approach. Kubernetes is the core of everything we do. We've got something like 20 different teams running on this platform. They all operate independently. They deploy their own services on top of the platform. And ideally, they don't talk to us too much. They just get on with stuff, build things. They come to us when they need support, but we're trying very hard not to be the, you must talk to us to get anything done. So we're managing these underlying clusters. And part of that responsibility is we need to make the costs visible to all of those teams, because otherwise they're just sort of running blind. They build some stuff. How much does it cost? They don't know. And that's where we've been stepping in for all this. So the overall tech spend is run by the sort of manager of our group with a foundation mission. Last time we gave this talk, he was in the audience, but Anton's forgotten to pack him this time, so can't point him out. He's setting our overall budget, and he sets that down to like AWS GCP, and that's something that we sort of have to look at and try and make this sort of broad spend things that we can, like costs, committed use discounts, Anton's going to talk about later, sort of general cluster optimization. But we also have these sort of individual budgets for different accounts, especially with the DevOps things, where it's completely under teams like the data team and securities control. And that's kind of simple as it stands. But then we've got lots of services running in platform, right? It doesn't do much good to have this giant platform budget and all the teams are looking at a small slice and, how do they save money? We've got all these shared costs like databases, Kafka clusters. Things like S3 buckets are generally simple. We can allocate those straight to a service. But all the shared stuff is a lot harder. And why do we care about all this? Isn't it just enough to set a budget at the top and have everyone work with that? As you might imagine, no, that doesn't work well at all. Getting individual teams to care about that giant budget is pretty hard. So we split up another 2 sets of budgets. We've got sort of domain type stuff, which is like the whole of those business units, like our internal business banking brand in the UK, some of the stuff we're doing for that bank as a service. And that's being looked at by the sort of engineering directors of those areas. But we also split out team budgets. So the individual teams have, how much they're expected to be able to spend, give them guidance on what they're doing. And we can also do things like take this data and give us like unit economics, like how much is it per bank account that we run. And yeah, where we were at the start of this, we did not have great tooling. We had sort of native tooling for AWS, GCP. AWS was quite problematic when we started. We got things like, all right, here's how much our EC2 instances cost. Right, that's a very big number for a lot of different teams, not very helpful. GCP's one was a bit more useful, but it still really wasn't that sort of split up enough for what we needed. We had this whole thing going on. We tried to shove it all into BigQuery, had someone doing internal work to try and analyze it, and basically that project just failed. It did not work. We didn't have the right analytics capabilities. We didn't have the right abstractions, like the sort of FinOps focus scheme. We couldn't blend AWS and GCP together. So with this disjointed, limited view, we didn't know how much we were spending where. We couldn't optimize things. Wasn't a great situation. So we had these budgeting difficulties. We had resources that weren't being allocated efficiently. This was all impacting our customer experience. We couldn't work on things. We really needed better cost allocation in Kubernetes. We needed to have this unified view so it wasn't all split across cloud providers. We needed reusable alerting so people could do that easily. And that's where we started partnering with Datadog.
Thank you, Mike. So yes, as Mike was saying, around the time of this failed BigQuery project where we tried to get everything kind of managed there, Datadog actually got in touch, telling us that they're releasing this new feature around cloud cost, and they'd like us to take it for a spin. So yeah, with that in mind, essentially we started a partnership with Datadog, so working with Natasha, who introduced us at the start, where essentially, yeah, we just kind of worked very casually to kind of figure out like use cases, what was working for us, what was being planned within Datadog. We got to beta test a bunch of kind of new cloud features at the time, so just the Google Cloud costs, some of the custom provider costs, and then cost monitors. And we also got these kind of monthly calls where we'd kind of like review progress on a casual basis, or we'd kind of plan next initiatives, and we'd kind of provide some feedback on different aspects of the product. Overall, this was really good for us. Like essentially doing this with Datadog at least was very good for us. Part of the reason was that we could leverage existing kind of labels that we knew very well, like the env label, the service label, and the team label. We also had access to all the existing dashboarding tools that everyone was very familiar with, as well as the kind of existing alerting tools that everyone was very familiar with. So really, it was kind of a no-brainer for us to kind of like dig deeper and try this out. And the partnership really helped to kind of like really explore this and kind of build on top of it as the product was being built, essentially. So yeah, the key benefits we had, I mean, the essential stuff we worked towards was Kubernetes cost allocation was the first thing that came in. That was incredibly useful. That just gave us bang for buck on day one. The multi-cloud costs came quickly afterwards, and that allowed us to get this kind of single pane of glass view, which was really good. Cloud cost alerting kicked in, which was really good. And then finally, the cloud cost recommendations also came in quite a bit later, and these are the ones that Natasha showed us towards the end of her section. Yeah, overall, these are the main kind of tools and features that we used and kind of provided feedback on. Now, we promised you a journey, so here comes the journey. And to give you a journey, I need to give you essentially a target or a goal, as it were. And so with that, we're going to essentially try and define what success means in the word of FinOps. So I'm going to reuse essentially a framework that's provided by the FinOps Foundation, because it's pretty good. Essentially goes from crawl to walk to run, classic, and uses 3 key metrics to kind of measure success. So the first one is cost allocation. Now, cost allocation essentially is how much of the money that is spent can you put back down to a service or a team, essentially someone that you can say, you are spending too much. Now, you want to essentially crawl when you're doing kind of, you're just getting started, you expect about 50% of your costs to be allocatable to an actual team that's causing it. When you get much higher, you expect about 90% of your costs to be allocated like that. The other one, CUD, stands for Committed Use Discount. That would not fit on the slide. Essentially corresponds to commitments that you make with a provider. You tell them, I will pay for X amount for the next 1 year, 2 year, or 3 years. And that commitment means that they give you like a deal, essentially, on your bill. You want to have as much of your kind of infrastructure covered as possible, so ideally 80% if you can. And finally, we have what we call forecasting variance. So this is essentially, if you set that you're going to spend a certain amount, by the end of that time period, by how much were you off? So 20% is like bad, and 12% variance is deemed to be good. Now, these numbers don't mean much, but they will as I show you our journey as we power through it. So with that in mind, we're going to start with cost allocation, and I'm going to let Mike take it over to talk about our tagging strategy and how we set that up.
Yeah. So if you're familiar with Datadog, you've probably seen like service tags, env tags. They sort of go right the way through the product. Team tag as well. One of the things that we use internally is Backstage as our sort of service catalog. In that, Backstage components correspond to services. We've also got Backstage systems. We've got a system tag that's running through things. We're probably going to be extending that to domains in the future, and that will fit neatly into everything else we do here. We start out with all of our cost data. We get the AWS costs, the GCP costs, the Datadog costs themselves. They all come in. We have the magic Kubernetes cost allocation. We just use the Datadog, which is pretty awesome, really. It just means we have the Datadog agents in all the clusters. It takes that data, it splits it up, and we get to see how much each individual service is costing us based on the underlying EC2 instances that it was running on at the time and how much of it took up. We also have a bunch of rules. We're using tag pipelines heavily. So we take some things that run taggable, like in AWS console and GCP console, you can't tag support that gets charged to us. So we tag that with something. We also, that Kubernetes cost allocation, it leaves out the wasted cost, that bit of the node that didn't quite get filled with pods because they won't fit. So we add on some special tags for that so that we always can keep track of how much, as a platform, we could be trying to do to reduce that. The Backstage data comes in. There's a really cool feature in Datadog where you can populate a reference table, which is just a CSV. So we've got a cron job that takes all the data from Backstage, uploads it. And then we take that, and all the data that comes in that's tagged on a service will then populate with team, with system. One of the interesting things here is that we've tried not to have people tag stuff with team throughout our infrastructure. We started with that, and then people kept reorganizing the business and moving services around between teams. And then it was like a week after that, it's like, oh, it's all out of date. Is anyone going to fix this? No. So we got rid of all the team tags. We keep the one source of truth in Backstage correct, and then that means we always get the up-to-date team information based on the services. While services move around between teams a lot, people tend not to rename the actual services themselves, which is helpful because everything keys off that. We had those cloud accounts we talked about before for like data security. We're not in as much control of those accounts, so we also add sort of team level tags to that so we can keep track. Again, the tag pipelines feature here lets us add tags without, we can add tags to stuff that doesn't have the tag already. So we're not going to overwrite anything, we're just going to fill in the gaps. And then new feature that's come in recently, we've got custom allocation rules. We can split stuff evenly by specific percentages, by metric. So we've been starting to use that now. So database costs, we're looking at the amount of query time a given service uses for a database to split the costs of that database cluster, so that the poor stateful platform team doesn't have a look at all this amazing amount of cost you're spending. And it's like, it's not our problem. Teams use this database. We can't control that. So we're giving that to the teams so that they can actually look at that and maybe optimize their queries, use less, let us downsize the databases. Support as well, when it's being charged as a percentage of your cloud spend, it's like, we'll just split that evenly based on how much the rest of the spend everyone's using. Lets everyone see the true cost of their services, which is the resource cost plus the amount that causes the spend on support. And finally, we get fully hydrated data, well, nearly fully hydrated. This is our sort of thing with crawl, walk, run. We've been improving. When we started, just the initial integration, just that Kubernetes magic at the very start, we had 40-50% allocated. We put in a load of Backstage tagging, we got to 70-80%. Last year, having done quite a bit of work there on sort of those tag pipelines, we were at 90%. And then most recently, with that new cost allocation rules, with a lot of digging for a lot of things. We're at like 96% at this point. And this is, I think, actually where we've gotten a lot of value just in this process. Where we've been doing all of this, figuring out through the cost management interface, we've got a bunch of dashboards that are like looking at how much is attributed, things that are missing various tags. And that's, sent our attention to various places that weren't being tagged. So we've had some interesting wins, like $2,000 in KMS keys per month that was completely wasted because we had some feature test running that would create a KMS key every time it ran, and they'd leave it alone. So the cost was just rising and rising and rising. And we found that because it was like, what are all these untagged things? We went and looked through it, figured out where they came from, and then it was like, ooh, not used. Another rather entertaining one was when a team came to us asking, why did our costs suddenly jump by several $1,000s a month? And it was like, why did your costs jump? Have a look through, and then, that was me, actually. I'd gone and found a bunch of resources, tagged these SFTP, AWS transfer stuff by the owning service, and suddenly the team realized that they were spending so much money on this service, and then went and deleted it from a bunch of accounts, because it wasn't needed everywhere. So yeah, tagging stuff is actually a really great way to figure out, what's not tagged, what's not being looked at, and then get rid of it. And yeah, one of the other ways we save money
is through committed use discounts. That was really smooth, thanks, Mike. So yeah, as I mentioned, committed use discounts are essentially about committing with a third-party provider like AWS or GCP to tell them how much compute you're expected to consume. That's in a dollar amount over a period of 1 to 3 years. You get a discount of between 30 to 70%, so it's not nothing. And yeah, each provider has different versions of it. AWS has something called EC2N compute saving plans. You can also do it for databases, and that's called reserved instances. GCP's got compute committed use discounts, which are very similar to the AWS ones. And they also, this is not strictly in kind of what's considered committed use discounts, but I include it here because it's quite interesting, or I think it's quite interesting, which is essentially BigQuery slot reservations. So I don't know how many of you guys use BigQuery, but that thing spends money like there's no tomorrow. And so being able to actually set a kind of limit on it is really useful. So with that in mind, right, so obviously, committed use discounts are awesome. They're a great way to save money. The main challenge or barrier to entry is that they're really hard to kind of determine and model. You have to make assumptions about how infrastructure is going to grow. You have to make a lot of decisions. Are we going to commit for 1 year, for 3 years? Are we going to do like a no upfront, where essentially you just pay monthly? Are we going to partially pay upfront, or we pay like part of that 1 or 3 year bill for like at the start? Or are we just going to pay everything in one go? Obviously, the full upfront is way cheaper than the no upfront, but then there's business requirements of like cash flow and all these kinds of things. Are you going to pick a single EC2 instance and be really specific on the ones that you choose? Or are you going to pick like an overall compute plan? Obviously, if you're more specific, you get a much better discount. And then you have to ask yourself questions like, what's the break-even time? And so this break-even time is if you get a 70% discount, then there is a period of time, usually 3 to 4 months, after which your infrastructure is technically free relative to what you'd pay normally. And so these calculations come into mind also. Datadog have introduced some kind of helpers for committed use discounts. I think they're mostly for reserved instances at the moment. Now, we're mostly Kubernetes, so effectively, as I was doing this, this is what I look like. So it was just really hard. It was, yeah, really painful. I did a lot of Exceling because I'm a manager, and that's what I use, Excel. And you'll be glad to hear that I'm not going to show you any of those slides, because they're, 1, terribly boring, and 2, it's just a lot. So instead, I'm going to go back to our definition of success and tell you kind of where we got to using Datadog cost to kind of measure our changing costs over time. So we want to get to coverage of about 80%. That's our golden standard. And so with that in mind, with our compute saving plans, we got to about 85, 95% coverage. The way we did this is we implemented a strategy where we get a block 3-year commitment that we kind of is our base commitment, and then every year we'll come back and we'll add an extra year commitment on top of it to kind of account for growth, essentially. And for reserved instances, I mean, those were actually relatively easy. We've got a couple of OpenSearch instances, and we're just like, these are going to keep chugging along, so we're just going to get 100% committed use discount on them. And then for RDS, we're currently exploring moving off of RDS, and so there's a bit of a do we not kind of aspect on it. So we did a bit of math and figured out 40% coverage kind of got us where we wanted to. Yeah, on GCP, we didn't implement any committed use discounts on compute because we don't actually use like that much compute on GCP. But BigQuery, however, did get a treatment, and essentially we achieved about 40% cost saving on it, which is awesome because, as I said, that thing is really expensive. So with that in mind, we get to our last point, which is forecasting variance. So To tackle this problem, essentially, we decided to kind of implement reusable alerts. The idea is that we wanted it to be very easy for people who own a budget to say, I want to spend this much, and I want you to tell me, like, in a way that is usable and actionable, what happens when I spend over or close to that amount. And so, again, the goal here is to get to about 12% variance if you can. So I'll show you where we started and where we got to. We're crushing it. I discovered as I checked it out afterwards. This is our overall bill. So this is AWS, GCP, and Datadog. And we're kind of within the bounds. You can see it's getting a bit kind of spikier more recently. So I don't know if we're not doing something as well. But if we dig a bit deeper, we'll kind of get a sense. If we split it by provider, we can see that in orange, AWS is kind of flat. It's going up a little bit, but nothing too bad. AWS is also our biggest kind of spend. Like, I think it's about 4 times GCP and about like 3 times Datadog. So obviously when that one wiggles, the rest of it kind of like wiggles a lot more. GCP, we've not been as good at, and I think that's partly because it's owned by other teams, so we're kind of dependent on others to kind of manage their costs as well, which we're educating them to do. And finally, Datadog, you'll see kind of spikes up and then goes back down. There is something quite interesting to note in this one. I noticed it afterwards. Datadog introduced Datadog costs into Datadog Cloud Cost Management. That was a sentence. Around, I think it was like October 2024. And you can see that's roughly when we noticed that our Datadog costs are getting out of hand, and then we noticed that we should probably do something about it, and therefore our cost collapsed afterwards. So these are quite useful, essentially. These alerts, as we put them in, really helped us kind of like motivate us to do something. So with that in mind, I'll talk to you about how our alerting system worked. Essentially, it's pretty standard. The person that I forgot to pack in my bag, Chris, who is our manager, is the overall tech spend owner. Now, this person essentially is going to be looking at a Slack channel, which is going to be the FinOps budget alert Slack channel. The budget owner, who kind of responds to Chris, or I guess answers to Chris, is going to decide on the budget, and they're going to set it up in Kubernetes using what we call a cloud budget, shortened to Cludget. And that essentially is a Kubernetes custom resource definition. It's just because we're platform engineers, so we like to do those. Essentially allows you to define it, GitOps it into your cluster, and then it will be synchronized to Datadog as a cost monitor, essentially. Now, the reason we do this is because it allows us to provide a much smaller API to define a much more complex set of objects under the hood, which is the Datadog Cloud Cost Monitor that will kind of do a lot of fancy stuff under the hood. Now, the Datadog Cloud Cost Monitor is going to look at a subset of cloud accounts in this case, and is essentially going to wait for costs to go above our expected threshold and then ping an alert to the Slack channel. When the alert is sent to the Slack channel, then the budget owner is going to look at it because they're going to be pinged, and the overall tech spend owner, Chris, who I forgot to pack in my bag, will also be involved and kind of get to keep an eye on it essentially and ask them to justify the excess spend so that they can grovel and ask for more money if required afterwards. Now, what this looks like in practice is essentially this. So on the left-hand side, you can see a bit of YAML. That is the only YAML for today. You're safe. Essentially, we describe our AWS platform budget, and you can see that we're essentially splitting out a couple of accounts, which are the Analytics Sandbox and Analytics Prod accounts. We've set a budget limit. I've blanked out the emails of people involved because PII, we're from Europe. And you can see that we set a budget limit as well as a budget forecast. Now, the reason we have this is because the budget limit is the absolute maximum amount you can spend, and you want that to blare as much as possible. And the budget forecast is more like, this is how much you think you'd be spending as the budget owner. You'd want it to be below the limit, because that might change over time, and you also want it to send you an alert if you're way below your expected forecast, because that does mean that you've not been predicting very well. So that's something to note. On the right-hand side, you can see essentially what that alert looks like. So from this tiny object, we've got something that will actually template out a bunch of links to useful dashboards that we've set up. So there's one for an AWS cost overview dashboard, one for like those specific accounts, and kind of grouped in different ways that are useful. And then you'll see it also adds a bit of a kind of action point telling them the next steps expected from you are X, Y, Z. And then you can see a conversation between a few of us groveling for money in the thread of that Slack conversation. So that's us, effectively. With that in mind, I'm going to leave you with a final kind of call to action, I guess, which is take control of your cloud costs. It's not that hard. It's painful, but it's not that hard. I'd say you can get started with Datadog Cloud Cost today. We'd vouch for it. We found it really, really useful. Again, going from this like tagging strategy to then measure your costs, do a bit of like cloud cost optimization with your committed use discounts, and then setting up alerting systems so that everyone could get in on the fun and managing their costs is kind of the way we approach it. So yeah, we also want to thank Datadog and Natasha in particular for the collaboration. It's been really good working with you, so thanks for having us, and thanks for letting us set this cost. With that in mind, I'm going to shift to Q&A and let you clap.
Awesome. Thanks, Mike. Thanks, Antoine. Thanks, Natasha, as well. Does anybody have any questions? We've got the mic in the middle. I can run you this one. You've been walking around.
Hi. So I'm in a very similar position that you're in, and I've managed to get the costs all the way down to containers and services. How, if maybe you haven't dealt with this, how have you dealt with when a container or a specific service is running a set of execution context is owned by other teams that own the service? An example of this would be there is a team that owns a platform within the platform, but basically a framework of running asynchronous jobs or some other workloads. And then product teams create a bunch of different execution context within that container.
Yeah. So this is actually, I think we've got basically the same thing with our Kafka platform, which we have not quite implemented yet, but they're working on it. This is that new feature Datadog have introduced recently, the custom allocation rules. So you can take your cost for that service, and if you then provide Datadog with a metric that has the right set of tags, service, sen, team, and so on, you can take the cost for that thing and then split it by that metric to those product teams. So you can say, we're not going to have any cost for the thing itself. We'll split it to all the teams using it. So the challenge there is, of course, what is that metric that we'll split that cost by? And that's where the Kafka team are currently working in our lot to figure that out. But once you've got that metric, you can split the costs, and everyone will see it for their thing instead of the internal platform.
I have a question about Spot. Do you use Spot instances at all?
A lot, yes.
Okay,
I didn't include it as part of our committed use discounts because, again, this is a bit tricky, but the FinOps framework doesn't strictly acknowledge it as a form of commitment, I guess. You just kind of plug them in. But essentially, we run our production environment on on-demand instances that get the committed use discounts. Databases, you don't really get Spot databases, so they're just running as is. But I think pretty much all the other environments are running Spot.
Yeah, pretty much full Spot for sandbox, dev, stage, etc.
We have considered running prod on Spot, but there are, emotional barriers to convincing people to do that.
I asked and answered. That's exactly, I was wondering where you put it in the FinOps framework so I could present it to my superiors. But I have I don't know if I can send you an article that one of my former colleagues wrote with AWS about how they moved everything, including prod, to Spot with Carpenter and saved a ton on their costs. And we've kind of used that same framework. But my second question is for the Kludget. I was wondering why you didn't start it with a K, because it's for Kubernetes.
That is an excellent piece of feedback, which we'll give to Adam for sure. Why isn't
Okay.
it we should probably do that with all of the stuff we release. I think we've got one at the moment. We're looking at cloud buckets, which are called Cluckets, but we should probably do it with a K.
But it should have two C's in the bucket part. You switch the C and the K, you have the same number of letters.
I feel like I'm the only person who is not insane about naming things. I keep getting overruled by all of them, and it's.
Well, thank you very much.
Thanks.
Other questions? Anybody?
Hey, so we're also using cloud cost management a little later. We only started a few months ago. Found it very useful. We have a very self-service platform, which is one of the reasons our costs just keep going up, because anyone can introduce a service at any time. Do you have a platform like that? How do you control the teams introducing new costs, which I usually find out about a month later or so?
We don't. Simple answer, we don't. It's very self-service. We do have some things implemented with Kverno policies in our Kubernetes clusters that enforce that every resource has to be labeled with an app Kubernetes IO instance label that matches a backstage component. So we've got, that's getting, there's some complexity in how that works, but it's all, we've enforced that relationship, and that means that we'll always know which service, which team, and so on. And after that, my view as sort of the core platform team is, this is not our problem. It's self-service, you're welcome to use it, and then your engineering managers and directors will see the budgets and will deal with this cost. This is a people problem, not a tech problem.
As an engineering manager, I'll hop on and say, it is my problem. So on that point, I will continue. Yeah, so I think definitely we let people deploy what they need to deploy. We're not there to tell them yes, no. We're not there to kind of guardrail when they can deploy something or not. We've tried out a few things. We've done it for like database instances. We will tell them no, reuse an existing one and create logical database as opposed to getting a whole new instance. And that process is already a bit painful and kind of a bit paperworky, and so it's not really providing the benefit we want. I think there are two things to bear in mind. One is like forecasting is one. So like obviously we'll just say we're going to have this many nodes in the future, so that's how much it's going to cost us. And that is pretty much an exercise where we go like this, add big error margins, and then see where we land. It falls roughly within our budgets because there are bits where we can kind of like mish and mash, I guess, to some extent. The other aspect, which is to do with how you actually get the teams to kind of be a bit more accountable or at least take ownership of their costs. So one, as Mike mentioned, we've got a tagging strategy where we know who does what, but we've also started implementing kind of, we've not fully rolled it out, but I've created this like really, really big Datadog notebook that essentially covers spend efficiency at a service level, talking about, I don't know if you're familiar with the tragedy of the commons, which is this idea that if you have a common good but individuals use it, then it's going to get drained because no one's coordinating how to use it. Yeah, shame is what I'll use to coordinate it, essentially. So we just have like a system that looks at all the Java apps and says, this is how much memory you wanted, this is how much you're using, why, and aggregate it at a team level to see how much they're wasting, spending, and essentially reallocate it that way. Now we're working on a system currently where we're using Backstage as our, what are we using? It's our service maturity framework, where essentially we're going to have metrics for each service that will just say, your spend efficiency is garbage, fix it, or you're doing really good, and you get an extra bonus point for doing good. So that's, I think, the direction we're going in. Does that kind of answer your question?
It does. I mean, it sounds very similar to the challenges we're facing. Same thing, which is, especially with the economic environment when growth has slowed. When we're growing, nobody cares about the cost, right?
So top tips, committed use discounts will kind of provide you a good saving if you can, if you're not running on Spot already.
We're running fully on Spot.
Oh, well.
The problem is we have created all the efficiencies, but the spend has stayed flat, which I guess is good, but it's because they're creating more and more. The engineering teams are creating more and more services. So we don't have a Backstage, we don't have a developer platform, but we let people create lots of stuff very easily.
One of the useful things that we have that we haven't, I don't think we're fully using across the board yet, but we have a couple of dashboards with it, which is like the unit cost economics. So it's the divide your cost by number of bank accounts, whatever the product metric is for your thing, and then you can demonstrate even if your costs are going up, if your unit cost is going down or staying the same, at least people in management are generally quite happy with that because it's like if we're bringing in more customers, we're getting more revenue. As long as the unit cost is going down, then we're increasing profitability, and that's how you avoid the conversations about why is the budget going up. All you need to care about is making sure unit cost doesn't go up. Which is still a problem, but maybe slightly easier.
Unit costing is something that we're kind of rolling out. We're quite lucky. 2 or 3 people in the product team are super switched on, and they're really wanting to get involved into it. I think they're interested from the perspective of actually making product decisions rather than just telling the engineers to save money. As in, they want to know, was this set of features powered by this actually worth it, essentially. And so that's, it's interesting working with them because we're just trying to help them determine the metrics they need to then build their dashboards. As opposed to doing the whole work for them. So.
Cool. Thanks. Appreciate it.
Perfect. That's probably just about all the time we've got for questions, but I'm sure you're both happy to take them.
We'll be outside,
yeah. Perfect. There will be a reception downstairs as well, similar to yesterday, so if you want to head down there now, then all that will still be open. And one final round of applause for Mike and Antoine. And Natasha, of course, as well, actually.
Cheers.